Recall that a relation is a set of ordered pairs. The domain of the relation is the set of all the first coordinates, or otherwise known as the x-coordinates, from the ordered pairs, and the range is the set of all second coordinates, otherwise known as the y-coordinates, from the ordered pairs. So the first example just simply asks us to state the domain and range of the relation. So the domain is going to be all of the x values, and the x values would be this -3, the 0, the 1, and the 2. So we could say that the domain is going to equal, and we draw this bracket here, -3, 0, 1, and 2, and then we close it with that bracket. And then the range is going to be the set of the y-coordinates, or the second coordinates. So that would be this 3, -7, -5, and 4. So we could say the range is going to equal, and do the same thing, 3, -7, -5, and 4. And that's the domain and the range. A relation can be graphed on a coordinate plane. A coordinate plane is formed by the intersection of the horizontal axis, or x-axis, and the vertical axis, or y-axis. The axes meet at the origin 0, 0 and divide the plane into 4 quadrants. Any ordered pair in the coordinate plane can be written in the form of x, y. So thinking back to what you've learned in other forms of math, the first number in an ordered pair tells you how far left or right you go. The second number in an ordered pair tells you how far up or down you go. Positive numbers go to the right and up. Negative numbers go to the left and down. So let's say, for example, we wanted to graph the ordered pair 1, -2. So the ordered pair 1, -2 is you would start at the origin, which is where the two axes meet. The first number 1 means we go right 1, so we'd go right 1 and down 2 for -2, and we would place a point there. Or if we wanted to graph the ordered pair -3, 1, the first -3, since it's the x value, means we go to the left 3, and the 1 means, since it's a positive 1, means we would go up 1. So we would just go left 3, so I should count 1, 2, 3, and then up 1, and then you would place a point there, and that's the point -3, 1. Notice that the axes divide the coordinate plane into 4 quadrants. Quadrants right here, quadrants. The names of the quadrants are numbers, Roman numerals. This is quadrant number 1. The upper left-hand corner is quadrant number 2. The lower left-hand corner is quadrant number 3. And then IV is the Roman numeral for 4. So it goes 1, 2, 3, 4, starting from the upper right-hand corner all the way around counterclockwise to the lower right-hand corner is quadrants 1, 2, 3, and 4. In quadrant 1, both of the x and y coordinates are both positive numbers because you're going to the right and going up, and those are both positive numbers. In quadrant 2, the x coordinate is negative, but the y coordinate is positive. In quadrant 3, both the x and the y coordinates are both negative. And in quadrant 4, the x coordinate, since you're going to the right, is positive, but since you're going down, the y coordinate is negative. So example number 2 says to name the quadrant in which the point -8, 5 is located. So -8, 5 is bigger than what our graph in our example graph shows, but since the first quadrant, the first coordinate is negative, the x value is negative, and the second number is the y value and it's positive, so that would be in quadrant number 2 right here, a negative first number and a positive second number. So the quadrant is quadrant number 2. So I would write Roman numeral 2. What if a coordinate doesn't have a positive or negative number? What if the coordinate contains a 0? Let's say we were asked the same question, and the coordinate that is locates the point 0, 3. 0, 3 means you wouldn't go left or right any at all, you would just go up 3. So that point would be located right there. Well, notice that's not on a coordinate. It's actually on one of the axes. It's on the y-axis. So we would say that the quadrant that 0, 3 is located on, it is not in a quadrant. We could say that it is on an axis. We could say it's on the y-axis, but it is definitely not in a quadrant. Ordered pairs are often the most common way to write a relation, where you have the first two numbers in parentheses, the first number telling you how far left or right you go, the second number how far up or down you go. But another way to write a ordered pairs or a relation is in a table. So notice that this table, the first column are the x values and the second column are the y values. 1, 2 has an x value of 1 and a y value of 2, and that's actually the exact same ordered pairs over here, 1, 2. An x value of negative 2 and a y value of 3 is showing you the exact same thing as this ordered pair, negative 2, 3. And 0, negative 3 in this table is showing you the exact same ordered pair, 0, negative 3 as shown in the parentheses. You also know that you can show an ordered pairs or relation in the form of a graph. So what are the ordered pairs of these points in this graph? So this point right here is the point, we go over 1 and up 2, so that would be the point 1, 2. And this point to the left, that point is located 2 to the left from the origin and 3 up, so that's negative 2, 3. And this point at the very bottom of the graph, that doesn't go left or right any at all, but just goes down 3 units, so that is the point 0, negative 3. So notice that is actually showing the exact same relation as what's in the ordered pairs in the table. And then the least common way of showing a relation is by a mapping, which looks very similar to a table, but there are arrows connecting the connected point or connected values in the ordered pairs. So 1 connects to the 2. That means when the x value is 1, the y value is 2. The negative 2 connects to the 3. So that means when the x value is negative 2, the y value is 3. And the 0 connects to the negative 3, means when x is 0, the y value is negative 3. So notice all 4 of these ways of showing relations actually show the exact same relations. They're all describing the exact same 3 points.